Hello friends, so this is our day 5 of problem solving for problem of the day from GFG. So let's look at the problem. Okay, so we are given a binary tree and we have to find the largest value in each level. Okay, so let's take an example and understand the problem. Okay, so this is our tree, right? This is our tree. So I hope you know what is level, right? So if this is my tree, suppose I am extending some values also. So this these values, okay. So these values are of level 2. This value is of level 1. These values are of level 3. Okay. So I hope you understand that. So if I extend more, 10, 11, 13. So these values are of level 4, or you can say also from starting with 0. So this is level 0, you can say level 1, level 2, level 3. So actually it's depend on the perspective. So if you are defining with respect to uh, vertex or node, okay, so if you are defining the levels in the perspective of vertex or node, so this will start from 1, and you are defining with respect to edges. This is an edge, this is an edge. Okay, so if you are defining with respect to edges, so this is level 0, this is level 1. So I hope you understand that. Okay, so if I give you like this as so if I give you this tree, okay, so if I give you this tree, like abcd are some values, d e f g uh, h I and j. Okay, so then this is level 1. So I am doing it with respect to vertex. Okay, this is level 2 values. So if someone asks me what are the level 1 values, so I will say a. If someone asks me level 2 values, I will say b and c. If someone asks me level 3 values, I will say d, e, f and g. Okay, if someone say level 3 level this is level 3, right? So level 4 values, someone asks me level 4 values, I would say h and I. Someone say level 5 values, I would say j. I hope you understand. Okay, so you understand. So what the example says, we have a tree, right? So in this level there is only one number. So among all the numbers, exactly one number. So the maximum is 1, right? So what we have to find is the maximum of all the numbers in each level. So for one, so for level 1, this is for level 1. Okay, so level 1 is maximum. So for level 2 there are two values, 2 and 3. Out of them which is maximum? 3 is maximum, right? So 3 is the answer for level 2. If suppose there is 5, 4 and 10, then for level 3 the values are 4, 5 and 10. So the answer should be 10. 10 is maximum among 4, 5, 10. So 10 is my level 3. So if I give you like 15 and 99, then what will be the answer for this level? it will be 99, right? Yes, you are right. So what I have to give is an array list, a dynamic array of all the maximum values. Okay, so for our example, we will give what, 1 2 3. So for this the answer is 1. So for this the answer is 3. So we will give 1 3. Okay, so we have to put them in array list and give the array list. So my answer is 1 3, as you can see here. So let's find an answer for some big tree. Okay, so suppose we are given this tree 1 2 3 10 20 30 40 50 60 70. So what would be the answer in this case? What would be the answer in this case, right? So for this level the answer is 1. For this level the answer is 3. For this level, okay, so for this level the answer is 40. For this level the answer is 60. For this level the answer is 70, right? So we will return 1 3 40 60 70. This will be my answer, right? So I hope you understand. Okay, so how we can solve this problem? So this is the question. So let's consider this 3 and see how we can solve this. Okay, so we are given this tree. So how we are going to solve this is using two stack. Okay, so what I will do is, actually this is breadth first search. Okay, so there are two searches, works in three cases. Okay, one is depth first search, another one is breadth first search. Breadth first search. Okay, so what is DFS? Suppose I am here, you are standing here, you go here, from here you go here to here, then you go here, then you come back here, then you again go here, then you come back here, then come back here, then go here, then go here, then go back here, then again go here. So you are observing what is going on. So I go here to here, then I go from here. So I am moving in depth. Okay, so I am moving depth, not like firstly I am just moving for level 1, and then I started moving for all the level 2 values, like from 1 to 2, then to 3, then to 4, then to 5 6 7, then to some other level values, then to some other level values, then to some other level values. I am not moving like this, like so. So what I want to tell you is, if I am moving like this, from A go B to D, then come back to B, then to E, so I am moving first in depth, right? So I am moving in depth. So this is depth first search. So I am searching, suppose, a value, keeping importance to the depth. Okay, so keeping importance to depth. So I am first searching in depth once, then I will search the rest also in depth manner. Okay, so I am searching A to B, B to D, D to B, come back in, then B to E, then go back, then again depthly C, F. So I am just this way I am just searching in depth. So this is depth first search. So what I need here is breadth first search. Okay, not depth first search. So I need breadth first search. So how is the pattern for breadth first search? I will go firstly A, then to B, then to C, then to D, E, F, G. Suppose this is H, I, J, K, L, M, N, I, M, N, O. Suppose P, then Q. So I will go from A to B, then C. Okay, so you are observing. So from here, I just go through all the level this level values. From here I just go through all this level values only, then I will go only for this level values, right? So from B to C, then to C to D to E, E to F, F to G, then to H, to I, to J, to K, to L, to M, to N. Then I will go here, then here, then here. So I am here initially, then I will go here, then to 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 here, then here, to here, to here, to here, like this. Okay, so I am searching in a breadth manner. I am searching the breadth ones. Okay, so not depth one. So why I need this in this problem? So let's understand that. Then we will see how we can do that breadth first search. So why we need this breadth first search here? So why we need this? So suppose this is a tree. So let's first recall what we have to find. We have to find, so the answer is in the question actually. So we have to find maximum of each level, right? Maximum of each level. Observe these two words, each level. So I have to find the answer for each level. So I have to traverse this each level. I will find max, right? I will add it to my array list. And I will just go through this level, find my max and add it to my array list. Then I will go the next level, right? So I am visiting level wise. Okay, so this is a breadth first search. So this is why we need a breadth first search, right? So I have to find answer for each level. Okay, for each level. So for 2 3 I have to find answer, then for 5 4 5 6 7 I have to find answer. So I have to visit like this. I have to visit 2 3, I will find the max, add it to the array. Then I will go here, and again I will visit like this in breadth manner. I will visit like this, I will find max, again next level. I will visit like this, find max, add it to array. Visit like this, find max, add it to array, right? So this is why we need breadth first search here. So I hope you understand. Okay, so how we can do this? Take this small example, or we can use this example also. So we need 2 stack here, right? So we need 2 stack here. One is my main stack and one is my child stack. So what are the contribution of them, right? So we have to understand. So the main stack actually, right? So main stack. So what we will do? First we will push this one, the root node, right? Then we will add all the children of it. We will add all the children of it, right? So the children are 2 and 3. So we will add them 2 and 3, right? Then what we will do? When adding them, I will compare the values actually. When I will adding them, I will compare the values of both of them and find the max. And so first I will create an array list and I will just push the one. So root node value, I will push the root node value. Then after that, I will create a loop and I will just, so firstly what we are doing. So firstly I am creating array list, creating two stacks. I am pushing the root node value to array list and pushing the node to main stack. And after that I will create a loop. So firstly we are just pushing our beginner values. Then I will create a loop and the loop will be running, right? So when the loop will be running, so I will add the children of this root node, which is 2 and 3. And when I am adding, when the adding is processing, when the adding operation is processing, I will compare and find the max in this time. When adding, I will compare the max and find the max. Okay, so I am comparing the values and find the max. So we are done. So obviously for first node the root node is actually maximum for first level, so we actually not comparing the root node. I'm directly pushing this, but for this one we have to compare, right? So when I'm adding this I will compare the values 2 versus 3, and who is winner? 3 is winner, so 3 will be my max, so we will get the max. Then I will do main stack equal to child stack. I will copy this whole stack into this, right? So I will be doing main stack equal to child stack, not one by one, because then 3 will be right here and 2 will be up of this. This is not a problem also, but we are doing this operation. I will directly copy main stack to child stack. Child stack to main stack, and child stack will be empty now. Okay, so my main stack is child stack now. So initially it was like this, and now after this operation, what are the situation? So my main stack is like this 2 3, and child stack is empty now. Okay, so we'll run the loop until we got the main stack empty and there is nothing to push into the child stack, right? So you will understand the more we solve. So now what we will do, same, we'll add the childrens of 3. Okay, so one thing I just forget. So when adding I have to pop this one also. Okay, so when I'm adding these childrens, the childrens of this node, I will pop this one and add this those childrens to child stack. Now what we will do, we will pop 3 and add 3 is childs, which are 6 and 7. Then when adding I will compare and find a max. Obviously there are more values 4 and 5, we will compare them. When, so after that we will pop 2 and push 4 and 5 also. So then here is a max, right? And comparing them we will get our new max, which will be actual max, right? So my max was initially something 0 or something value. So comparing 6 and 7 I get a winner. So between this winner and 4 and 5, between the winner of 6 and 7, I will compare 4 and 5. So 7 will be the winner. So I got the max for this level also, right? So let this have more values, 8 9 10 11 13 14 15 16, right? So then what we will do, again I will so my main stack is empty now. Okay, but here is child stack. So after the loop, at the end of the loop I will just do this operation, main stack equal to child stack. So child stack will not be empty at the last, right? So now I am doing this operation, main stack equal to child stack. So all the values will be transferred here, 6 7 4 5, and this is my child stack which is empty now. So I will pop 5, add all the children of 5, 10 and 11. I will then comparing the values, I will get a value for max. I will pop 4, add the children 8 and 9. I will compare the latest max with these two and get a new max, right? I'll pop 7, add the children of 7, 13 14. I will compare the new max and these two values and get a new max. I will pop 6 and add okay, so last time I popped 7, right? So it will be 15, 16. Then I pop 6 and add 13, 14, and the new max will be compared to 13, 14. I'll get a new max, right? So this will be my latest max, which will be the maximum of this level values, right? So I will get my answer, add it to the array list. So then I will go like this, main stack equal child stack again. So my main stack will be like 10, 11, 8, 9, 15, 16, 13, 14. Then what we will do, I will pop 14, nothing to push because 14 has no children, so it will be empty. Pop 13, no children. Pop 16, no children, so no children will be added. Pop 15, no children. Pop 8, 11, 10, no children. So after that, after doing main stack equal to child stack also, so the child stack will, after doing main stack equal to child stack, the main stack will remain empty. So my loop will be terminated and we will get the answer as we have did it. Okay. So why this is working, I hope you understand why this is working. Because in the child stack, listen to my words carefully. So what we are doing, here is a main stack, here is a child stack, right? So we push first one, then add the children of it 2 and 3. So we actually got all the level values. So if you are thinking that there may be other children, so these values are not here, right? So yeah, so let me finish the problem, then you will understand. So after that, what I am doing, after that I am doing main stack, child stack empty, right? So then I am popping, okay, so here is 2, here is 3. Popping 3, I will add 6, 7, compare values. Then I will pop 2 and also I will add 4, 5. So you get it. So I ultimately get all the level values here in my child stack. Because until my all these level values which are in here got empty, I will keep adding values. So what are the values here in this level? They are the children of these parents. So the values here is the children of these parents. So I am not actually doing this main stack equal to child stack until this is empty. And when it will get empty? It will get empty when all its children are in here, right? I am saying once again, this tag box is storing the childs of this box. So here are the parents, okay, here are the parents, here are the childs. We will not do main stack equal to child stack until we got main stack size as 0. And when we deal with 0, when all the parents will be popped and all the children of these parents will be added to this child stack. So what are the values? They are the children of these parents, right? So if I create a box and I push all the children of all these levels, then actually I get all the values of here because they are the children of these parents, right? So that's why it's working. So here are my parents, and here are my children. Okay, so I am not actually vanishing the parent until all the parents came. I am saying once again, I am not vanishing my parent box or my parent stack until all the parents came and give their children to this stack. So when all the parents came and give their children to this stack, actually we got all the values of here, because all the values here are all the children of all the stacks here, right? All the children of all the parents here, sorry. So that's why I actually getting all the values of here by doing this operation. So you will get actually all the values in my child stack. Okay, so now let's code, you'll understand better. Okay, So I'm last one more, we will just do it this little example. So this is my main stack. I will push this one. I am creating my child stack. I will pop this one, add my 2 and 3. Okay, I will do main stack equal to child stack equal to new stack. I will pop this one, nothing to add, pop this one, nothing to add. I will do main stack equal to child stack, which will be still empty, child stack equal to new. This time my main stack is empty, so I will terminate the loop. So I actually got up. So when adding this one, I already did the maximum thing, so I got my result, right? So first time I added 1, second time when adding 2 and 3, I compared and find the max. So the max is here already, and after that terminating, so I got my answer as 1 3, right? So this is why the thing is working. So let's code now. Okay. So what we will do, we will first create an array list. And create a queue. Okay, create a queue, stack of node, right? We are storing node for the stack and integer values for the array list, which is my answer, which is our answer. So this is our main stack and this is our child stack, right? Which is our child stack, this is our child stack. And then we are pushing our node data, and pushing main stack the root node, right, which is node. Then we'll create a max right, and create this loop until our main stack size becomes 0. And here we will first pop the main stack's node. So from main stack we pop, then we will add the children to the child stack, right? Child stack. So I have to check, is there any left node? So if there is any left node, I will create the left node to the child stack. I will push the root node, right, root left. Then here, so when I am adding, so here I am adding, right, I am adding to child stack. I will compare here the value of root.left.data. If it is greater than max, I will update my max, right? Okay, and I'm writing my second children, which is root.right. So I have to check it is null or not. If it is not null, I will push it. Push what? Root.right, and compare. Right? We have to compare. This is our duty, right? Yeah, and then at last we will check if our stack size is 0 or not, right? So if it is 0, what we will do is we will update our max firstly. So I'm checking is our max is already is not updated or not. I will tell you, I will try run this thing, don't worry. So max, then add this to my array list and restore the initial value, and main stack equal to child stack equal to new stack, right, and I will return my answer. Let's compile it. Let's check if there is any mistake. No mistake is there. Okay. Oh, got a mistake. Sorry. Mistake. So everything is fine. Let's submit it. Yeah. So we got it, right. So let's have a look. So have a look how our program is running. So have a look at it, right. So just building on these things, and so look at the program, and we will compute this thing. Okay, and this is our rough area. This is our main stack, this is our child stack. Okay, so firstly we are adding our node, root node, right. So one is added, then we are sorry, this one is my array list, and so answer. So my answer is here. Suppose this is my answer array list. So here I am adding my node data, which is 1. Then I am pushing my node. So this is my node actually, not the value. So I'm pushing the node. So then this is my max. So actually for max, so I hope you know identity, right. So for the integer, so for integer and real numbers, the identity is 0 for positive operation. Okay, so the identity is 0 because if you add something, you will give the value you are added. If you subtract something, okay, so for subtraction it is, I don't know. So what I am telling is identity is something that when you will do the operation, you will get the value actually, not the identity. So suppose there is one value and there is your identity value. If you are doing some operation, you will get your this value. Okay. So for in real number, the identity value for the addition operation is 0. So similarly, what I am trying to say is that the max operation, the operation max, where it means the maximum number. So integer dot mean value, it's a very long minimum value, right? Something negative. So what I am trying to say is that there is a number x which belongs to this integer class, and there is this number, this max number. So if I find the max and this x, I have x. So suppose x is 2 or 0 or negative 1000. So if I find the maximum of negative 1000 and negative this big thing, which is the most negative number of integer, so I will get actually minus 1000 back, right. That is why this is identity for max, and similarly for min the identity is integer dot max value. Okay, so we are taking identity, as in sum we take 0, right? In sum, if I have to find the sum of series, so I will take sum value as 0. Okay, so this is the reason. Okay, so what I have, was I, so yeah, so I added one. Then until our stack is empty, I will pop this one. So I pop this one and add my left data and right data, right? So I add my left data and right data, and when adding, I will compare my max value, which is very negative value, to this value 2. So I will get my max as 2 first. Then when coming to this right section, I will compare it with 3. So I will get my updated max as 3, right? So after that my max is not equal to that value, very negative. So I will add my answer to this. So I will add 3 here. I hope you get it. So then main stack equal to child stack equal to empty. So this becomes my child stack. This becomes my main stack, and here is my child stack. So again I pop, again the loop goes, and I pop from main stack and add the left value and right value. So left value is 6 and right value is 6, and comparing the value, the max value is 3 and I got 6. So maximum 3 and 6 is 6. So I got 6. Then when adding the right node, I will compare right value to max value, right? Right value to max value. I will calculate 6 to 7. So max is our updated max. So from 6 and 7, we got 7 as my max, right? So right. So I will then pop 2 and add 4, 5. When adding 4 and 5, I will compare this to 4 and 5. So my max will be remain 7. Then I will add this, as this is not this big negative value. So I will add this to my answer, 7. Then main stack is child stack is new. So this becomes my main stack, right? This is my child stack. As I will pop this one. So here is a condition, root dot left is not equal to null, then I will add. So it is null, so nothing to add, so nothing to compare also, because compare will happen when this is non-null, right? So because this if condition is under this if condition, so nothing to add, nothing to compare. Pop this one, right? So why all of them are popped? Because all the childrens don't have any children, so that's why. So I hope you understand that 5 is popped. So let me finish it with honesty. So 5 is popped, no left, no right. Again the loop goes. Again 4 is popped, no left, no right. Stack is not empty, still empty. Stack is not empty, right? So again the loop goes back. 7 is popped. Again the loop goes back. 6 is popped, right? So when previous time when we last added 7, our max, we reset our max as that bigger integer value, negative integer value, right? So this time when all are popped and our main stack is empty, actually our max is still this negative value, so we are not adding this one, right? So then the loop goes and the main stack is empty, so the loop terminates. So now all of them are popped, so main stack is empty, right? So this loop terminates and we return our answer, which is 137. So I hope you enjoyed. So let's see in the next video.